Have you ever stopped to really think about the sheer power of a lightning bolt? I mean, we're talking about 1 billion volts of electricity. It's 5 times hotter than the surface of the sun, and it's all unleashed in a split second. It is, without a doubt, one of nature's most incredible shows. But in our superconnected world, that amazing spectacle is hiding a very real, very modern danger. And to really get it, we need to look at a place that gets hit more than pretty much anywhere else.
Okay, so what you're seeing here is the Burj Khalifa in Dubai, the tallest building on the entire planet. And it's taking a direct hit from a massive bolt of lightning. It is an absolutely jaw-dropping image, right? Looks like something straight out of a movie. But this isn't science fiction. This is a real clash between our greatest engineering and nature's raw power, and it's happening all the time.
And that really brings us to the big question we're going to tackle in this explainer. It sounds simple on the surface, but the answer? Well, the answer tells this fascinating story about technology, about our hidden vulnerabilities, and about how we can protect this incredibly complex, smart world that we're all building.
So let's start with the star of the show, the Burj Khalifa itself. You have to understand this isn't just a tall building. It's basically a vertical city, and it's an absolute masterclass in designing for extreme weather. Now, here's the crazy part. This isn't some rare once-a-decade event for the Burj. It gets hit constantly. We're talking dozens of times, sometimes in a single storm. And yet, inside, the lights stay on, the elevators keep moving, the thousands upon thousands of electronic systems don't even flicker. It is a true modern marvel of protection. But it also shines a massive spotlight on a critical weakness in almost every other building out there. So, yeah, while we're all staring in awe at the Burj, there's this hidden danger that's growing in our offices, our hospitals, and yeah, even in our homes. See, as our buildings get smarter, they're also getting more fragile in ways we're just now starting to really grapple with. Just take a look at this number for a second, $952 million. That is the value of over 65,000 insurance claims from just one series of thunderstorms in Australia, right over a recent holiday period. And we're not just talking about broken windows here. A huge chunk of that is from sensitive electronics getting completely fried by power surges.
And this slide, this shows you exactly why. On the left, you've got the past, right? A traditional building, pretty simple, just a few ways for power to get in. But on the right, that's today. That's a modern, smart building. It's this complex web of literally thousands of interconnected devices, building management systems, IoT sensors, climate control, you name it. They're all talking to each other, and they're all vulnerable. Every single one of those connection points is a potential doorway for a destructive surge. But here's the real kicker. While we all picture that dramatic movie-style lightning strike on the roof, the data tells a completely different and pretty surprising story. A staggering 80% of the power problems that kill our electronics actually start from inside the building itself, just from big equipment like air conditioners cycling on and off. So the storm outside is really just throwing gasoline on a fire that's already burning inside. So here's the bottom line. We've kind of created a perfect storm, haven't we? We're building these incredibly tech-dependent buildings, filling them with super-sensitive microelectronics, at the very same time that our climate is giving us more intense, more frequent storms. We are more connected, and because of that, more vulnerable than we have ever been before.
Okay, so that's the problem. But the good news is, just as the problem has evolved, so has the solution. We are way beyond just sticking a simple metal rod on the roof anymore. We're now talking about a comprehensive, intelligent shield that's designed for the 21st century. At its core, a modern lightning protection system, or LPS, has the same goal it always has, even back to Ben Franklin's day. Catch the lightning strike and guide all that energy safely into the ground. But how it does that today, well, it's become incredibly sophisticated. A modern LPS really works in 3 coordinated layers. First, on the outside, you have to capture the strike before it even touches the building. Second, on the inside, you have to control the powerful surges that can still sneak in through power lines. And finally, you have to safely dissipate all that massive energy deep into the ground. All 3 have to work together perfectly. So let's start at the top. Capture. So this capture phase isn't passive anymore. This is not your grandfather's lightning rod just sitting there waiting to get hit. Modern systems are actively sensing the electrical charge in the air during a storm. They can actually initiate their own connection, basically reaching up from the building to meet the lightning bolt halfway. This creates a much more predictable, controlled path for that energy to follow, guiding it safely away.
This handles the big threat from the outside. But what about that 80% problem from the inside? Well, that's where the other layers come into play.
Now, this technology is really impressive, no doubt. But there's one place where it goes from being impressive to being absolutely critically essential, and that's in our hospitals and healthcare facilities. In a place like that, a power surge isn't just an inconvenience. It can literally be the difference between life and death.
I mean, just think about it for a second. A surge takes out the HVA system, you could lose the sterile environment in an operating room. The data center goes down, patient records gone. A failure in the electronic door locks, you could have staff and patients trapped during an emergency. Every single system failure has a direct and potentially catastrophic human cost. And then you have the life support equipment itself: ventilators, dialysis machines, patient monitors. These devices are the very definition of mission critical. They cannot fail, not for a millisecond. And a standard backup generator, well, it's not fast enough to protect them from the instant damage of a massive power surge. And look, if you think this is all just some theoretical what-if scenario, it's not. Back in 2017, a hospital in Florida got hit by lightning, and both its main power and its backup systems failed at the same time. 225 people, patients and staff, were suddenly plunged into darkness. That is the nightmare scenario that these modern protection systems are designed to prevent. So if the stakes are really that high, what's next? Well, the future of lightning protection is shifting from just being reactive to being predictive. We're not just learning how to handle a strike anymore, we're learning how to see it coming. And this is where it starts to feel like science fiction. By feeding just massive amounts of real-time atmospheric data into AI and machine learning algorithms, these new systems can predict the immediate risk of a lightning strike with over 85% accuracy. I mean, think about that. That gives you a crucial 15 to 30-minute warning, which is enough time for a smart building to automatically go into a protective lockdown, shutting down non-essential systems to brace for impact. It's a total game changer. And the innovation is just picking up speed. We're seeing brand new materials like graphene for better conductivity, smart grid integration, and even autonomous drones that can fly up and do safer, more accurate inspections of these systems on top of skyscrapers. The entire protective shield is getting smarter by the day. You know, when you look back at the whole journey, it's pretty incredible. We went from Benjamin Franklin and a kite, a totally revolutionary idea at the time, to simple rods, then to basic surge protectors in the 80s. But in just the last handful of years, we have made this enormous leap into an era of intelligent, predictive systems that are just as complex as the buildings they're designed to protect. Which brings us all the way back to our big final question. Our world is definitely getting smarter. We're surrounding ourselves with incredible technology to make life more efficient. But with every single new device we connect, we create a new potential vulnerability. The story of lightning protection really shows us that for our world to truly be smarter, it also has to be more resilient. So the real question is, are we building that resilience fast enough?